Hello students, here now we are going to see what is the meaning of half-life. So let us first see the definition for half-life. It is the time required for the reactant concentration to fall half of its initial concentration, or we can say that it is the time taken by a substance to become exactly half of its initial concentration. Now students, what is the meaning of this? That is, if I start with a substance, say for example A, whose amount I have taken or the concentration I have taken as 100 gram, and say for example its half-life is 2 minutes, then exactly after 2 minutes this 100 gram will become 50 gram. Means it is becoming exactly half of its initial amount. Now after the second half-life, this is the first half-life. So after the second half-life, the substance will now become 25 gram. Now students, this 25 gram means exactly half of its initial, means 50. Now what will be the amount will be after its third half-life will be 12.5 gram and so on. So what is half-life? Is the substance when it becomes exactly half of its initial amount, that is the time what it takes, that is called as half-life. Half-life is the characteristic of any substance. Usually the radioactive substances like uranium, thorium, they have their specific half-lives. And after that specific half-life, they become exactly half of their initial concentration. Say for example, today I have started with uranium-235 92 and its half-life, say for example, is 5 minutes. I have taken 100 gram of uranium, then this will become exactly half after its first half-life. Means it will become 50 gram. Means student, if I start with 1, it will become half after the first half-life. After the second half-life, it will become 1/4 of its initial amount. And next half-life, it will become 1/8 of its initial amount. And this will continue. If I try to take this uranium and I heat this or cook this at a very high pressure or at a very high temperature, or if I try to put some catalyst to it, or I try to bring about any type of reaction and convert this uranium to its oxide or chloride, in that case also uranium will have the same half-life. Means students, half-life is a characteristic property of any substance. Whatever changes you make either in the pressure or temperature, or you add catalyst to this, the half-life of that substance will not change. So this is all about half-life. You represent half-life by this notation, that is T and a half below it. Now let us see the derivation for this. For this derivation, you have to take help of the integrated rate law for the first order, and that integrated rate law equation is K is equal to 2.303 upon T log to the base 10 of A0 upon AT. Now student, if the initial concentration, if I say that is initial concentration is A0, then what will be the final concentration after time T or the half-life? So therefore the AT or the final concentration after time T, this will be exactly half of the initial, means A0 by 2. Substituting this in this equation or equation 1, what you will get? This you have to write student, that from integrated rate law for first order reaction. So you got this equation. Initial concentration here is A0 and now AT we will replace by A0 by 2, means the half of the initial. Now students, we are deriving this for half-life, therefore we have to replace this T also by T half. So what will be the equation now? K is equal to 2.303 upon T half log to the base 10 of, this will become A0 upon A0 by 2. This A0 and A0 will get cancelled and it will become K is equal to 2.303 upon T half log to the base 10 of 2. What is log to the base 10 of 2 is 0.3010. So K is equal to 2.303 upon T half into 0.3010. 2.303 into 0.3010 will give you a constant, and that constant is, so K is equal to 0.693 upon T half. Now students, we are deriving this for half-life, so I will rearrange this. T half is equal to 0.693 upon rate constant K. So this is the equation for half-life calculation for a first order reaction. Now students, let us see what will be the graph for this. So we have to see the graph for the concentration of the reactant, how it falls. So here, if I try to plot the graph for concentration of A with respect to time, then what will happen? You know that the concentration will continuously fall. If you see this, concentration is decreasing. So the graph will be something like this. Right, students? Now, if you see this was the initial concentration. So, after the first half-life, the concentration will become exactly half. So, this is your first half-life. Similarly, you can show the graph in this way. This will be your second half-life, third half-life, and so on. So this way the concentration goes on decreasing as the time passes. So this is all about half-life. I hope you have understood the concept of half-life. So please do like this video and share it with your friends, and don't forget to subscribe my channel. Thank you, students.